consider the following image. If we look at this image, we see it looks like a trigonometric graph. In fact, it looks like the regular sine function because it goes to the origin here and it reaches a maximum there, but we can't say for sure because we do not have any labels on this graph. Before we can make any conclusion, we need to have the intercepts with the horizontal axis. We need to have the maximum value, we need to have the minimum value. The only thing we have is sort of a scale on this picture. Now look at the same graph where I've added some labels. You will see we have an intercept with horizontal axis at A, which is a value of minus 180. Then the next one is at C, which is at 0 degrees. The next one is at E, which is at 180 degrees. And then we have another one at 360 degrees. And this is when we draw the graph in between minus 180 and 360 degrees. The next thing we realize is that the minimum value, we can read it off now, that is negative 1. The minus is not as visible as I want it to be, and then the maximum value is at 1. We have on this piece of the graph, we also have another minimum, which is also the same as that at B. So this is now the labeled graph. So now we can make some conclusions regarding this graph, like for instance properties like the period or the amplitude, etc. The first property we have to look at is the period of the graph. The period does exactly what it says it does. It measures how far must the graph go before it repeats itself. So in this case, if we start at A, move down to B, up to C, up to D, down to E again, we see if we now go from E to F and from F to G and further on, this part here, E, F, G, is a replica of A, B, C, that part there. So from A through B, through C, through D to E, we have one cycle of the graph. We can calculate the distance by taking 180 minus 180 degrees, which gives us 360 degrees. We can take any part of the function. We can start at C, and we can say from 0 we go up, and then down to E, down to F, and up to G, and if we have a more graph shown here, more of the image, then we'll see that that piece there is exactly the same as the piece that will follow from G onwards. So the period again is 360 minus 0 degrees, which is 360 degrees. We can measure this period from any point on the graph. For instance, from B, we can go to D and down again to F, and then it will repeat itself. It doesn't matter that whether we start at 0, we can use any point. But the matter of the fact is that the period, the length in which the cycle, that part of the graph is repeating itself, is just 360 degrees. The next thing that we need to look at is the amplitude. Now, amplitude, the definition of the amplitude is the maximum minus the minimum divided by 2. In other words, we take plus 1 here and we say minus 1. So we get the answer of 2 and we divide it by 2. So that just gives us the distance of from the horizontal axis to the maximum, or the distance from the horizontal axis to the minimum. And that is for a graph in standard position. So in real life, most sound waves are either sine, cos, or combinations thereof. So it's quite an important function to consider and look at its properties. And the higher this D is, the louder the sound will be. So in simple words, the amplitude is just the maximum minus the minimum divided by 2. In this case, it is plus 1 minus 1 divided by 2, which gives us just 1. So the amplitude is 1. So let us look at the roots. When we talk about the roots, we're actually asking whether what is the solution for all the values here on my horizontal axis. Easy to read off. So we can read it off: minus 180, 0, 180 and 360. We can even write a general formula for the roots. We see it occurs each 180 degrees. So we can start with any number, like for instance 0 degrees, and then we can add k times 180 degrees to get to all the roots, where k is a whole number from negative infinity go through minus 3, minus 2, minus 1, 0, etc. So if k is, for instance, 0, then we will get back the value 0. If k is 1, we will get e. K is 2, we will get g. If k is negative 1, we will get a, etc. So the extremes, we can also write general formula for the extremes, and that will happen. The minimums will be at b and at f, and we can again say, okay, let's start at, we know the extremes are minus 1 and plus 1. So let us start with, for instance, at b we have a minus 90 degrees. And then we add k times. Where do we the next minimum occurs? It occurs 360 degrees further. So we can say k times 360 degrees. The next thing that we look at is the maxima, and it will be exactly the same, but the starting point is different. It is 90 degrees plus k times 360 degrees. On the next page, I made a summary with all the properties, and you can use that as a must-know sheet to keep it for yourself. This is now what we discussed on the previous page: the period of 360 degrees, the amplitude, etc. We've listed all the roots, where they appear, what they are. In the general formula, I like to write a 0 plus to give me a starting position, but you can leave it out because it doesn't matter if I add 0 or not. And here's just a summary of where does the extreme value occur. The minimum at B with its coordinates, and the minimum at F with its coordinates, and the maximum at 90 with its coordinates. You're welcome to work through this must-knows and print it for yourself.